Hello everyone, this is Griffin Kindred and I'll be showing my video for the Project 1 of Aerospace experiments. Go to inch, we will zoom out just to be able to see, kind of have a good reference when we make a rough sketch. And for my model, it's going to be the origin of my model is going to be at the middle of the test section. So now that we have that, let's make some constraints. Let's make everything horizontal that needs to be. And first I'm just going to make the test section, whoops, let's do that later. Okay, let's just make our dimensions here. This is going to be, the height is 22 for the length. Actually, before we do that, let's just make everything symmetrical real quick. We're going to just make the test section symmetrical. Let's make it sure that this is all good. Okay, and these are symmetrical. There we go. And these two, just to make sure. Okay, there we go. All right, now we can make a height of this 22. Let's make the length 15. The length of the line for the contraction length is 24. The length of the test section will be 12. And the length of the diffuser is 42. Real quick, I'm just going to make the vertical line symmetrical with the test section, so I have the origin here. And that messed up some things, so I gotta figure out what happened there. Let's just keep making dimensions then. For V7, the height of the test section is 6 inches. Okay, let's see if that... There we go. Okay, so the middle of the test section is the origin of the model, or the origin of where the model is. Okay, now for dimensions, we will have our angle from here to here is 3, but for some reason it makes the angle from the other side. I don't know how to fix that, but that's okay. I just do 180 minus 3, which is 177. And let me get rid of these lines because they're no longer needed. And that should be our test section, or that should be our wind tunnel. Now we can sketch from surface, apply, generate, and that is it for the geometry. Next, we go to mesh. Okay, so we have our model here. Let us update it. Now it looks like that for now, but we need to change that actually to method, select the geometry, apply. We are using the triangles, so let's update that. It should just be some triangles now. Let's just generate it real quick. There we go. So now we need to make the triangles a lot finer, and we do that with metric orthogonal quality. The element size is 0.007, and let's update and generate it. There we go. So now we have our super fine detailed mesh. I believe everything else is in order here. Very good. So now the next thing to do is to go to make the surfaces. So we go to cursor mode, edge, and we have our inlet, our outlet, or sorry, I meant edges. And now we can click all of these. We'll call it ton wall, apply, and update. And that should be it. And let me just check one thing real quick. In my geometry, I want to make sure, okay, so everything is in inches. Good, good, good. Okay. Now we are on to setup, double precision, start. And here is our wind tunnel. Let's report quality, orthogonal, very good. Check, good, good. And now the first thing we need to do is, like the video showed, I'm just going to follow the video. You turn the energy equation on. K epsilon, enhance wall, pressure gradient. Okay. And then materials, fluids, air. Change, create, close. Okay. So now what we need to do is set boundary conditions for inlet. Now this is where we will be putting our velocity, magnitude. For 10 Hertz, we plug it into the v-test section, but what we also need to do is, because of the contraction ratio of 9, we need to divide what we get by 9. So for v-test section of 10 Hertz, I got 2.1172 divided by 9 is 0.235. So I'm making 0.235 as my velocity magnitude. Apply, close. And now the next thing I need to make sure I do is make sure my residuals are good. So I can go to solution, methods, or not methods, residuals, and I need to make everything, it's too, the number is too high. Let's just make sure that's low. Okay. And one more thing I should do before I start my calculations is the reference values. So we're computing from inlet, velocity is there on the surface body, and that is good to go. Okay, so now that I have that, we can initialize. So Let's go to initialization. There we go. Oh, whoops, I missed a part. I forgot to make it 300 iterations. Okay, let me go back. Nope, that's in our reference values. No, it's not. It is. No. Okay. Run calculation. There we go. 300 iterations is what we want. Calculate. Alright, sorry about that. For some reason, when I was calculating, it wouldn't work unless I paused my recording because it just didn't want to work. But anyway, we calculated. As you can see, we ran all the iterations. It just saved time to pause it, and for some reason, it just wasn't working. Okay, so now what we want to do is create our contours. Now, this is the first part of the project. So we need to create 4 different contours. One for static pressure. So we'll call it static pressure. And we need to have everything on. Compute, save, display. So there's our first one. Next is, let's do total pressure. All of them. Compute. There we go. Next is dynamic pressure. And the last one is velocity. There we go. So now that we have our 4 contours, the next thing to do is part 2, which is plot the variation of velocity, static, total, dynamic pressure along the center line. So we want to go to the horizontal center line. So to make this horizontal center line, we will go to where is it? We need to make a new, there we go. We need to create a new line. So for the middle of my, so we need to go from the however much left the inlet is from the origin and however much to the right. I already took the liberty of doing the calculation, so it should be negative 1.811 to positive 1.811 meters. I had to make sure to convert inches to meters because that was something I messed up. So this is the horizontal center line, part 1, create. And now let's make sure we can see it. So we go to our mesh, which is oh, there it is. Let's go to mesh. And let's display. There we go. So we can see we have a center line going from left to right down the middle. And now the next thing is to plot our XY graphs along that. So we want to make sure we have the horizontal center line, and we will plot the static pressure first. Let's call it stat pressure H center line. For horizontal center, our direction is 1, 0, 0, and we are good to go. Let's save and plot. So there's our first graph. That should look about right. So the next thing we do is make 3 more. So the next thing is the dynamic pressure, H center line. And there's that. Let me see something real quick. Okay, no, we don't want that. So there is our dynamic pressure. You can also go up here to new. Let's do the total pressure H center along that line, and we get kind of a weird line going here. And lastly, we need to plot the velocity, I believe. Yes. Velocity H center. And there we go. That is part 2. Now for part 3, we will be doing the same thing except with a vertical line that goes straight down the middle of the test section. So what we want to do is what we did for this one, except it's going to be just a little different. So let's just show our mesh here. Let's display. Okay, so let's create a new line. We will call this vertical center line because it's going up and down. This time we want the lines to run from 0, 0, because that's where I made the center of the model. So we need to go from negative 0.0762 to positive 0.0762. Create. Now let's take a look at it. Whoops, not the wrong one. And there we go. It's smack dab in the middle of our mesh, which is good. So now the thing we want to do is same thing, just do it again. So static pressure vertical center now. Just V for vertical. And let's do that. Save plot. That, since we're going vertical, the Y needs to be 1 now. So there we go. That's what our static pressure looks like. Let's try that again. We want 0, 1, static pressure, B center. Save plot. Okay, this is what we get. Close. New. Now it is dynamic pressure. Make sure this is 0 and this is 1. There we go. So that's our dynamic pressure. Total pressure now. I don't know why that went back to, let's try that again. There we go, looks much better. And now let's make our velocity. Velocity B center. 0, 1. And there we go. As you can see, we got little dots at the bottom too for no slip. So that is part 3. And last part is we need 3 points, 1 for the inlet, 1 for the outlet. So let's show our Michigan. There it is. Let's just get rid of that display. There we go. Okay, so now what we want to do is make 3 points. 1 right at the beginning of the contraction, 1 at the end, and 1 in the middle. So to do that, we need to make 3 points. So we are going to call this, we'll call it contract inlet. And I've already done the math for it from the origin of this. Now the y is 0, so create. As you can see, it's right where that contraction starts, which is good. Did that save? I need to make sure that save is that. Okay, now let's make another one. Point. Contract outlet. And I've already done the math for it. Negative 0.15 meters, y is 0. Create, as you can see, right on the outlet of the contraction. Close. And last one is to make the point exactly in the middle. Now I made my test section middle 0, 0 on the model, so this is just 0, 0. As we can see, boom. Great. And now we have our 3 points. Let's make a mesh to show that. As you can see, we have our 3 points, one at the inlet, outlet, and the middle. And now what we need to do is make our, we need to find our calibration constants. Okay, so what we need to do is go to parameters. Oh, sorry. Parameters. Here we go. Great. And now we need new area weighted, I believe. Yes, area weighted. This is the contraction inlet. And this compute. There we go. Okay. Our new one for our outlet compute, as we can see right there, and the new area weighted for our test section. Oh, whoops, my bad. This needs to be dynamic. The first two were static. This needs to be dynamic. There we go. Okay. We can select all of them if we want, and compute, and it shows all of them here. Create output parameters.
Good job, bro. I don't think the dragon egg really does anything. That's big.
Sorry about that. This should compute, but as you can see, we have our contraction parameters. We'll be repeating this whole process again with a different velocity, which we will be able to get. We plug in these values in the Excel. I don't know why it's not responding, but basically from here, I'll get the 3 outlet parameters. Let me pause real quick to see if that. Okay, there we go. I'm back. Sorry about that. I just need to pause it so it would run. And now we have our 3 output parameters. And once we have that, what I like to do is go to simulation report. Here we can do a whole report outline, which we will be able to have everything, just a good way to get all the information I need for the final report. And that's how you do it. Thank you very much.